Welcome, everyone. Here we are on day 3 already of our virtual summit, Transforming Decision-Making in the Public Sector with AI-Powered Geospatial Data. Thanks for joining today. As the population of the U.S. continues to grow, so does the infrastructure that supports that growth needs to be planned for, created, and maintained. Fast-growing urban areas are accelerating changes in the environment and driving needs for new access to transportation, vehicles, bicycles, and pedestrians. Having access to good data is essential in planning and keeping up with the needs for moving goods and people across the country in an efficient and a safe way. Hello, everyone. My name is Dan Ross. I'm a strategic advisor for the public sector here at Ecopia. Prior to my time here with Ecopia, I served 28 years in the public sector in technical and leadership roles related to information management and GIS. I will be your facilitator today. We are talking data again today on day 3, and specifically how high-resolution geospatial data can assist you or your organization in planning, analysis, management, and decision-making as it relates to transportation and transit. Our presenters today are Bill Singleton, Tricia Vivian, and Sean Race. Bill is the vice president here at Ecopia and has been with the company for 8 years. His main responsibility is engaging with geospatial analytics partners to find new ways of combining vector-based maps with alternate data sets to help public and private entities better understand and improve communities in which they operate. Previously, Bill spent 5 years working in enterprise sales at Cisco Systems Canada, providing data center and voice solutions. Following this, he graduated with an MBA from the Ivy School of Business with a focus on entrepreneurship and managing high-growth companies. Tricia Vivian is the GIS administrator at San Bernardino County Transportation Authority, where she manages GIS infrastructure and performs transportation planning and analysis on behalf of the agency. Her career has evolved around learning the best ways to leverage GIS in county and municipal government. She has led various projects for San Bernardino County Flood Control District, County Stormwater Program, and most recently at the SBCTA. Sean Race is a senior transportation planner at FAIR and Peers. He specializes in geospatial analysis, data science, and data visualization. Sean has experience in working on systematic and local roadway safety projects, active transportation, and safe routes to school projects, as well as first last mile studies and local and regional field inventory pursuits. He has an acute skill set in developing data dashboards for public outreach, internal use, data management, and storytelling. He has also conducted research, performed outreach, and provided education programs in the area of goods management. Welcome to each of you, and my thanks for joining today and sharing your story. Bill, let's start with you. Ecopia has come out with some high-resolution geospatial data that can clearly enable and benefit organizations and individuals who are involved in transportation and transit management. Can you share with us a little bit about Ecopia and your vision as an organization?
Absolutely, Dan. I want to first start off by thanking our host and all of the participants here today, and thank you for taking the time to learn a little bit more about our organization. As mentioned, my name is Bill Singleton. I'm the vice president here at Ecopia AI. And over the last 10 years, our organization has been using the latest in machine learning to extract highly precise geometric map data across 100 countries across the globe. Our vision is to digitize the physical world across the planet. But what does that really mean for you? It means that we want to completely eliminate the painful and frustrating work of manual digitization to accelerate the efficiency of GIS and planning teams by providing the best, most accurate vector map data from the latest aerial imagery sources. We want to help your organizations create visualizations faster, finish statistical analyses in a more efficient manner, and help you with your work with modeling applications. So what have we built? Our team has built a content service that can help out to extract upwards of 45 individual map features from the latest 3-band aerial, street view, oblique, and LiDAR data. When we initially got our start, we actually were working with satellite information as presented earlier this week, extracting some basic features like building footprints and roadways across many countries and federal governments across the globe. But what we recognized was by using that same technology and increased and better resolution in terms of our input data, we can expand that portfolio to a much broader set of asset management of identification properties. And that's really where we see ourselves today, starting to expand that portfolio to not just look at things like impervious surfaces that help with applications like stormwater, but really helping with everything in the transportation right away, whether that be with pedestrian items or things that deal with how everybody moves around their cities today. One of the most important things to keep in mind is, as I mentioned on the last slide, we did initially get our start with satellite imagery, but our process is completely image agnostic. So we can use many different kinds of input data sources in order to conduct our analysis and to create our geometric base map data. This allows us to not only take advantage of customer investments, whether if they have purchased their own aerial information data sets already, or we can help by work with our large partner network of aerial sources across the country, whether they're looking for coverage, recency, higher resolution, or more frequency, to even working still with satellite sources if you need something that's an immediate change detection analysis after an emergency event, whether that be with flooding, or forest fires. So there's a lot of availability with our team to be able to work with many different sourcing. One of the most important things that I like to stress with our customers is these are not the typical automation tools that you might be familiar with, similar to eCognition and some of the other pieces that are available in the marketplace. A lot of that software requires a lot of in-house knowledge, a huge in-house knowledge basis, and requires a lot of parameters that need to be set and a lot of training data that needs to be collected. And a lot of the results that end up coming out of those analysis tend to be sort of in the range of 60 to 70% accurate at the end of the day. And so really what we are focused on is building an in-house proprietary set of tools that we use in order to produce vector map data that doesn't require any post-editing on the customer side. We really want to be able to help you get started by using not just our automated tools that are in the cloud, but also our GIS experts who triple check all of our results and create our training data sets so that we can help the feedback loop of our iterative process and improving results for all of our future projects with every new project that we take on. I'd like to just quickly take one step back and give you guys some a visual cue of what we're trying to do across the United States. This is actually an area and a project that we did where data was presented to public sector public sector organizations across Maryland. In this example, you'll see an aerial coverage of the base map data that we started with. And then what you'll see is the OSM data that has been layered on top of all of the sidewalks and pedestrian pathways that are available in the public sector. This is an example of what Ecopia is building on top of aerial and satellite sources across the nation. So you can see a significant increase in the amount of coverage, which will be discussed by our partners a little bit later on in the presentation. But you'll see that it really expands the accuracy and the amount of content that can be kept up to date on an annual basis by our organization. We can even go one step further. And in this example, we're actually showing the width measurements of each of these pathways that is across this region. And so you can see here, anything marked in green is above 6 feet in width, and anything marked in red is actually lower than 4 feet in width, which actually is a problem for American with Disabilities Act requirements across your region. So you can see that we're not only identifying vector geometry, but we're creating information that can help you tip and cue future projects for your organization.
Thanks for that great background, Bill, and even the example. It really tells a story there. Can you share a little bit more about the use cases for this data and how it aligns and can assist organizations with their transportation related management efforts?
Absolutely, Dan. So I wanted to, instead of diving too much into the technology, I really wanted to give you guys, to give the teams specific examples of how our data is being used with public sector transportation applications across the US. We're already working with 9 of the top 10 Council of Governments and MPOs across the nation and many different state DOTs. And these are some of the initiatives that we're looking forward to, that we are supporting at the moment. As you can see, we've the list is quite broad and can go from anywhere from network analysis to safety to equity to even federal reporting requirements, so that we can help you apply for funding, so that you can win more construction projects and use other sources of funding. One of the most exciting projects that we actually worked on, before I get into the specific examples, is our collaboration with NOAA in supporting the Coastal Change Management Program. Our teams have already been identified at being able to create precise vector and raster map data at scale. And so we are already working with federal entities to build nationwide data. And this allows us to work with local and state transportation groups now to build out that portfolio without those groups having to front the entire cost of the project. And so this is something that we're really excited about, by bringing multiple groups together so that we can collaborate on a more complete data set and remove some of the data silos that exist in today's data environment. So this is a quick example of some of the imagery that we will typically intake into our process. And as you can see, this is from a top level, and we'll get a little bit more detailed from here, but we are doing wall-to-wall vector extraction that is helping not just CMAP, the Metropolitan Planning Agency for Chicago, the Illinois Department of Transportation, but also NOAA's Coastal Change Management Program. So all 3 entities are being able to, are seeing a benefit from a one-time review of us intaking aerial imagery and producing the results for their group. In this particular project, we're extracting actually upwards of 23 features with over 40 attributes. And if we were to simplify it, we can sort of go even application by application. This is the same area where we're identifying ADA ramps, so the truncated domes on curbs. And we're able to do this from aerial imagery. Now, we're obviously we're not extracting the slope of curbs from the aerial imagery. That's something that we can work with additional partners on, as you might see a little bit later in the presentation. But really what it does help you do is it does help you have an understanding at a high level where surveying efforts might need to be required, and where there has been some work and where some work has already been done. As we've seen, a lot of this inventory is sometimes not centralized, and so it can make getting these projects started a little bit more difficult. This is an example of us extracting. This is looking at just the transportation assets and features from this. So similar to our sidewalk analysis, we actually did a project working with the Southeastern Michigan Council of Governments a few years back, where they wanted to extract all of the sidewalks and crosswalks of their area for a network analysis. And from that network analysis, they were able to determine that over 75% of their population was within 100 feet of their nearest sidewalk. But that did mean over 20% of their population also required access to some of these closer assets, because some of those populations are actually the ones that are using mass transit the most, and they require access to those kinds of facilities. I will move it along because I do want to have the opportunity for our partners to go over some of the detailed analysis that they're doing with the vector data. But you can see here there's a number of other features as we continue to focus in that we're able to extract while we're doing some of our national level projects. So identifying features like medians, other active transportation features like bike lanes, and even looking at things like tree canopy that intersects with some pedestrian walkways, which I've seen very important in areas like California, Texas, and Florida, where they want to understand the comfort level of certain pedestrian access and being able to walk in shaded areas so that they use these assets. The last two examples that I'd like to quickly talk about before I hand this off. This is a slide that was actually developed by the Texas DOT. This is even just looking at one specific region around the Austin area. And so this was the national data set that they had access to, and then compared to what Texas DOT had for their region. This was actually in support of a climate resiliency requirement that they were looking at trying to identify all of their local roads and bridges. And so you can see here that Ecopia was able to identify up to 38,000 linear miles of roadway coverage, of local, of not just state roads, but local roads as well. And this is actually even important for the Meyer requirements, the model inventory requirements that are coming up in 2026. Ecopia can help you identify paved and unpaved roadways across your entire state so that you have an understanding of how many roadway elements are required to identify so that you can maintain that federal funding. So really, we want to just provide a much more broader sense of high-level information and keep that up to date on an annual basis for you. The last example I'd like to give, I'm actually very excited about. It's with paint striping. And so this is actually, this has been helping for public works and also for permitting across local cities. And so you can see here that I'll bring up another example here. Even with some occlusion, our organization is able to understand where all the paintway markings, whether they're turn symbols, whether they are identifying different kinds of laneway requirements across the entire regional city area. So we're really happy about this new development that we're starting to build out across all of the metro regions, and look forward to speaking about it a little bit more in the presentation.
Thanks for that great background, Bill. Tricia and Sean, you're also working with geospatial data in the transportation area. A little bit more about what's going on in San Bernardino County, and Sean, with your work and how you're using that work and that data to improve outcomes of the efforts you're working on.
Yeah, thanks, Dan. Thanks, Bill, for the warm introductions, and thanks again to everyone in attendance for carving out some time on your Thursday to sit in on this dialogue. Again, my name is Sean Rossi with Fair & Peers, and I'm sitting alongside Tricia Vivian from SBCTA. And today we'll be sharing some insight on how San Bernardino County prioritizes the use of geospatial data on regional and local planning efforts and engineering efforts, and is constantly evolving their practices in using data to better inform decision-making and touch on how Ecopia's services sort of help enhance the development of a digital representation of the county, both at a regional and local scale. So just a quick agenda of the topics that Tricia and I will be going into. I'm going to turn it over to Tricia in a second to highlight some past and current planning efforts that SBCTA has undertaken, then shift the conversation to highlight some key data insights that SBCTA has developed over the years to assess existing transportation conditions, analyze and forecast current and future travel patterns, and discuss how they integrated big data into their projects. Then we will highlight a recent active transportation project that was largely data-driven, then wrap up with a highlight on how Ecopia served as a value add on this project and will continue to serve as a key data set moving forward. So with that, I will turn it over to Tricia to highlight some past and current multimodal projects.
Sounds good. Hi, guys. As Sean said, my name is Tricia Vivian. I'm the GIS administrator for SBCTA. And just some background on what SBCTA is. It is works hand in hand with the San Bernardino County Council of Governments. And so it is all of the county and the cities working together just on transportation goals together. We regionally work with SCAG on a lot of projects. SCAG is Southern California Associated Governments, I believe. So, you know, we all work as a team to kind of meet certain goals. And so just on this slide, I listed out some plans that SBCTA is undertaking. Which one, or the one that I did not list on this slide, was the RTP SES. And I know the Council of Governments throughout the state are required to kind of work together on that project. It's a really big project. So I kind of just wanted to highlight that and how that leads into our LRMTP, which I'll explain too. So the RTP SCS takes in it, well, the RTP stands for Regional Transportation Plan, and SCS stands for Sustainable Community Strategies. And so what that is a huge regional plan that it's not just our county. It's about, I believe, 5 counties in one are making this regional plan that addresses things like housing, air quality, economic development, population, transportation strategies, land use. It looks at all these things, and what SCAG is responsible for is proving, like on paper in this plan, how they're going to reduce greenhouse gas emissions and then vehicle miles traveled. But that kind of leads hand in hand to how when something's regional like that, that doesn't always show what's true in a smaller section of land. So what we did as SBCTA, we developed what's called a long range multimodal transportation plan, LRMTP. I'll go to the next slide. So that is our way of kind of taking all this data together, looking at things like demographics, travel patterns, vehicle, active transportation, transit, safety, air travel, emergency evacuation data. Those are just some of the data sets that we look at to kind of come about with this big picture plan that helps us to better plan for the future. And I know I'm sorry, Tom is my husband. Sean is going to talk more about our sidewalk inventory program. And some of that data that was used in that plan is going to be used in this LRMTP. So it's really exciting to see how all of these projects, they may be like have a different focus at the time, but in the end, we use all of these data sets together to kind of achieve a big goal, and that's to have better sustainable planning in the future. So with that, I'll pass it off to Sean.
Yeah, thank you, Tricia. And as you can see with each one of these projects, it's clear that the use of data to inform decision-making, network development, project prioritization, whatever it might be, is integral to the success of the project and the outcomes of that project and the longevity of them and how they'll be used into the future. And as most of you are aware, data collection, data management, analysis, and visualization is cumbersome. Historically, project discussions around data analysis were largely static and fixed in time, inhibiting deeper interaction with the task at hand and the underlying results. However, in more recent years, this perception has changed. Agencies and consultants have prioritized the evolution of the status quo by enhancing data interaction through web-based dashboards, e-plans, data hubs, and other web-based solutions. And right at the center of that evolution is SBCTA. The data they manage and the projects they deploy for agencies within San Bernardino County are comprised of some sort of web-based solution or a living plan per se. And this slide shows a small sample of solutions that were developed for both public and agency use. On SBCTA's GIS portal, users can access data dashboards that dynamically display population forecasts, the existing and proposed bicycle network, active transportation safety and connectivity, and so many more. And these dashboards enable agencies within the county to understand how the existing conditions of their jurisdiction fit into the regional picture. The upper right screenshot of this slide is the homepage of, I just wanted to highlight this, is the homepage of an Esri story map that contains maps, data, and resources relating to active transportation across the county, from walking and biking to transit and community demographics. And this plan serves as both an encyclopedia for active transportation projects across the county and as a foundation for agencies to use in grant applications. And the outcomes of the projects that Tricia mentioned will be appended to this constantly evolving document. And this is sort of the foundation and like ground zero for a lot of active transportation analyses, results, and deployments moving forward. So as SBCTA evolves their use and deployment of data, so does the data. The data is always evolving. I feel like it's every day now. In the information age, the movement of people and goods generates an enormous amount of data. Therein lies the potential to add great value and insight when planning transportation decisions. Big data is no longer an emerging technology. Big data options are diverse and adaptive and can be used to address both simple and complex questions through advanced technology and insightful analyses. And if you're standing on the side of a road, let's say in downtown San Bernardino or Ontario, and you take a snapshot of the transportation environment in front of you and within your peripheral vision, chances are good that the big transportation data pool is high. So from connected and autonomous vehicles to GPS units and satellites, the amount of data we readily have access to is astounding. And so SBCTA has integrated big data into their projects and has found success in communicating findings in a way that is digestible by technical representatives, technical minds, and sort of the layman's delivery of it, and so digestible by all. And so the fact sheet on the right compiles, it is just an example of how SBCTA has effectively visually communicated big data results. And so this fact sheet on the right compiles census and community profile data with location-based service data to paint a picture of how, why, and where residents and visitors of the county move. And these visual communication successes have helped shed light on agency travel patterns that historically went unnoticed. So now that I've kind of groomed you with an overview of SBCTA's successes in geospatial data analyses and deployment, I just wanted to shift the discussion to a specific active transportation project led by SBCTA that tapped into a diverse pool of geospatial data. And this project is called the Comprehensive Pedestrian Sidewalk Connectivity Plan. This project was two-pronged, spanned over a half decade, and recently concluded in February of this year. And the main goals and objectives of this effort really was to assess the existing pedestrian environment at a countywide scale to identify areas in need and opportunities for growth, ultimately facilitating improved pedestrian connectivity, enhanced neighborhood mobility, improved active transportation safety, and community connectedness. So Tricia alluded to this in one of her slides earlier, but San Bernardino County is the largest county by area in the entire country. So you can imagine how great the data collection lift was for this effort. In phase one for this project, SBCTA staff conducted a countywide sidewalk inventory that traversed over 8,000 centerline miles and collected and inventoried 17,000 miles of sidewalk to curate a comprehensive database to identify where sidewalk exists and is missing, the material of the sidewalk, and the width of the sidewalk. They augmented this sidewalk inventory with a pedestrian obstruction inventory that aimed to identify existing pedestrian obstructions such as pavement uplift, bus shelter intrusion, and other obstructions in high pedestrian demand areas of each city in the county. They then summarized the results of the sidewalk inventory into a city-specific connectivity fact sheet to present a snapshot of how connective every city's sidewalks are, especially to key points of interest like schools, parks, and transit stops. SBCTA then overlaid the results of this inventory with historical collision data to identify areas of concern and in an attempt to find correlations between areas with deficient or lack of pedestrian infrastructure with historically high rates of pedestrian-involved collisions. And then one of the core outcomes of phase one, core deliverables of phase one, was an ADA transition plan toolbox that was sort of intended to present guidance on using the data inventories in phase one to help agencies identify and prioritize sidewalk and crosswalk improvements as part of their plans to comply with the Americans with Disability Act, called the ADA. And then came phase 2. So throughout the duration of phase 1, project stakeholders in the project's technical advisory committee were consistently voicing how the data from phase 1 was of interest to their local active transportation planning efforts, especially as they relate to safe routes to school planning, climate adaptation planning, and ADA transition planning. SBCTA recognized that for this data to have an even more usefulness in longevity and future-proofing it in planning activities, more data features and a higher resolution inventory should be conducted and set forth. And so phase 2 set out with the goal of conducting a high resolution inventory to assess ADA compliance of sidewalks and curb ramps in high pedestrian demand areas in each city and community across the county. So if you can remember in phase 1 collected the locations of sidewalks and obstructions along a subset of existing sidewalks, but didn't capture any measurements related to the sidewalk segments. And so these sorts of measurements that we set out to collect on phase 2 are vital for cities to achieve implementation of ADA transition plans. So cities need to have a comprehensive database highlighting where there is ADA non-compliance or deficiencies of pedestrian facilities in the public right-of-way. And so phase 2 set out to collect these measurements on 750 miles of sidewalk across the county, which is roughly 10% of existing county sidewalk, split into a standard network of 10-foot segments. And these measurements included sidewalk running slope and cross slope, level change, width, condition, obstructions, photos of the sidewalk, and all of these sort of compiled into what is called a route accessibility index, which is a priority score that serves as an easy way for cities to identify where there is deficiency or potentially not ADA non-compliance at a 10-foot segment level. So that bolded route accessibility index in the map on the right, if the segment is red or the score is higher, there's likely some issue maybe related to level change or uplift, or there's a significant running slope that is causing those segments or those areas to be non-compliant with the ADA. Phase 2 also inventoried 2,500 curb ramps across the county within these high pedestrian demand areas with the same goals in mind to identify ADA non-compliance of curb ramps. Again, measurements included ramp running and cross slopes, phase of construction, if applicable, so if the curb ramp was built, missing, or in construction, the length of the ramp, presence of detectable warning surfaces, and the curb ramp types. Now, you're probably asking how come this effort wasn't county-wide? Well, you can imagine the level of effort it takes to assess ADA compliance of sidewalks and curb ramps countywide at a 10-foot segment level and a curb ramp, like individual curb ramp level. So this inventory and plan, the primary intention of this plan and this inventory effort was to provide a self-evaluation planning blueprint for cities to rely on moving forward as they continue assessment of all the remaining sidewalks and curb ramps within their city. So at the kickoff of this project, I know this slide looks very similar to something that Bill covered earlier, but at the kickoff of this project, and as we were scoping out relevant data to collect, SBCTA emphasized a need to collect additional features along and adjacent to the roadway. That's where Ecopia services really pose as a value add to this project. There's really no need for me to go into additional detail of what the services that Ecopia provides, but at a high level, we pulled high precision vector data from 2020 aerials for the urban areas of San Bernardino County to augment our sidewalk and curb ramp inventory. The features that Ecopia extracted for us included sidewalk pavement width, which may seem repetitive at this point, since we collected sidewalk and width during phase 1 and phase 2, but really this served as a valued purpose for validation to compare how measurements were being quantified across different data sources. We collected travel lanes and widths for every roadway. So there's a key vector, a key data set that was pulled from this project. On-street parking, roadway medians, on-street bike facilities, landscape buffers, driveways, tree canopies, which is, it's really informative to know what does tree canopy coverage look like over existing sidewalks, because San Bernardino County gets very hot. And so we want to know how shade is sort of covering where existing sidewalks are, where there's no shade in their sidewalks, where there's no sidewalks in their shade. So having that overlay is key. And then truncated domes and bus shelters. So you can imagine this data paired with the phase 1 sidewalk inventory and the phase 2 high resolution sidewalk and curb ramp inventory really helps paint a picture of the existing pedestrian environment as it relates to the roadway and adjacent roadway features. But in order to effectively deploy this data and the components of this plan, we had to be strategic in how we present it. So there are 24 agencies, 24 or 25 agencies across San Bernardino County, each with their own initiatives, sort of vision on how they want to build out and progress transportation planning, active transportation planning, and ADA transition planning into the future. And so we wanted to compile the guidance, the objectives, and the results of this comprehensive pedestrian and sidewalk connectivity plan into an informative and dynamic E-plan is what we called it. And that what this E-plan is built on is an Esri story map, and every agency has access to each of their own custom E-plan that is set out to give a high-level overview of the sidewalk and curb ramp ADA compliant snapshot of those high pedestrian demand areas of the city that we collected data in phase 2, give ADA transition plan guidance and current agency status on achieving implementation. So there's key components of implementation of ADA transition plans. Where does the city lie on sort of progress to achieve that? We went really into detail on the self-evaluation component of ADA transition planning. So we gave guidance on how to do that. We discussed the data vendors that we use to collect and evaluate pedestrian facilities within the public right-of-way. We put everything together into a dynamic data viewer. I touched on this earlier in my presentation. Being able to have data at your fingertips to interact with it as deeply as you'd like is something that is just, it's not state of the art anymore. It's just, it must be deployed. It must be used on projects moving forward. So we wanted to uphold that strategy and that foundation that SBCTA is always pushing for. So all the data, whether the Ecopia data, the sidewalk data, the curb ramp data, community demographics, was all compiled into a dynamic data viewer that basically unlocked the ability for agencies to dive into the existing conditions of their city. We gave a sample ADA transition plan so that once they get to the point of identifying where the deficiencies lie and the schedule to remediate those deficiencies, how can they mold their own transition plan to fit like what standard transition plans look like. And then we have given access to jurisdiction-wide sidewalk data, ADA compliance data, and aerial image extracted data for agency use outside of this effort for future planning efforts. And so, as you can imagine, with the evolution of big data, the evolution of data visualization software, different types of data, the opportunities for how we look at data, literally look at it and put ourselves into it, is constantly evolving. And so I'm going to turn it back to Tricia to talk about a potentially unique option that SBCTA is exploring to pair the Ecopia traffic lines, those travel lanes and widths, maybe building footprints, tree canopies with proposed bike projects, pedestrian enhancement projects, in a 3D setting. So Trisha, I will turn it back to you.
Sounds good, Sean. Let me go to the next slide. Okay, so as Sean mentioned, from this project and from some of our other projects, we just have been getting so much data, and we don't want that data to sit on a shelf. We want people to be able to have access to it, or at least have it be usable by our member jurisdictions. So something that we've been looking into lately was to put this data in a 3D space. We will be working or are talking to a company where we can work on a project where we put all of this data into a 3D area, and they use a game engine called, I believe, correct me if I'm wrong, Sean, but it's Unreal Engine. And awesome. And they make it so that you can explore the space. It's not just like an aerial image, it's something that you can kind of go through and envision things. So where I see a lot of value in it is to take, some of this data that we've collected and popping it in there, and then showing what stuff could look like in the future, what it looks like now and what it could look like after maybe a major project. When we kind of looked into the demo of this, we looked at the before and after of what a bike lane and sidewalk addition would look like if you were to add it to a community without that. And I think it's just really powerful when you pair that in something like a story map where you can tell a story. You can either share that with the public, you can share it with decision makers and really give them a visual on what things look like or what things could be. I think that that adds a lot of value. And things that we can do or projects that we can look at in 3D space can include active transportation corridors. you know Ecopia gave us landscaping, lanes, different things. All of that combined equals one big picture. We can I'm not sure how to say it, but I just think it's great to look at that all together. And I think, Sean, unless you have anything else to say on that, I think that's it from us.
What a great story, and what a huge amount of data that you've spent time collecting. And I think it's really cool that you're now trying to come up with ideas for where you can take the data next. With that in mind, we've heard some great stories about data today, and from Bill and from Sean and from Trisha. Let's go to our audience and see what questions they have for all of you. So audience, please put your questions into the Q&A tab, and we will go from there.
And I just wanted to point it out. I did see the question in the Q&A that said, where can I find more information on SB's pedestrian connectivity plan? And I popped our link to a story map in the chat. If you check out the story map and click on the Take a Walk tab, you can find some more information out about the projects that we were talking about.
Bill, this next question is kind of probably for you. It's and I apologize if I murder the name, Shreya. Is this kind of data available for India?
Yes, so absolutely. That goes to a little bit of our introduction. When we initially got our start, we were looking at a few basic features, and that's where we started really expanding with not just our imagery partners, but some local partners that we have both in the aerial field and some of the data aggregators and other individuals who add on top of our data. So we have done a number of different features. I would say that in terms of the transportation space, it doesn't include items like throughway and turning lanes, but we do have data sets that incorporate pedestrian right-of-way, natural features and tree canopy, 3D building data, and a number of other features that we've collected from a number of different sources.
Thanks for that, Bill. Let's keep going with our audience. Trevor's asking, has SBCTA seen greater success in agencies' grant pursuits with this data?
I'll jump in with that. I think that's kind of something that time will tell, but we are constantly applying for new grants. I'm constantly making graphics for new grant applications all the time. And I feel like this year, especially, it's been a big push. So having all this data is great. And we can kind of key in on projects that we want to work on. And yeah, I definitely see a great value in it.
Yeah,
Well, this,
yeah. I'll also add to that. We are actually working with a number of pursuits on the East Coast to help with grant applications for things like Safe Streets for All, and then also I was actually just at a statewide, the American Association for Highway Transportation Officials, and the Federal Highway Authority has told us specifically that you can qualify for highway improvement funds to collect MIRE, the model roadway elements data. So even just collecting basic things like intersections, paved and unpaved local roads, there's funding available for that. And the HSIP funds are over $3 billion this year, split based on size of state across the country.
great answer. Thanks for that. Sean, you mentioned that big data is here and we're all going to have to deal with it. Our next question from our audience, Margarita, asks, satellite images are usually quite heavy, especially if they are high resolution. How do you store the images for the large areas, and how do you deliver these images to your clients if required? Bill, that's probably you, but there's probably a component in there for both or all of our presenters.
Yeah, that's a great. We're actually running into that with a lot of the work that we're doing across the state of Illinois. Essentially, we're working with 16 individual MPOs, and some are like Chicago and San Bernardino with fantastic set of resources and internal enterprise tools, while others might not even have the equipment or infrastructure to house a terabyte of aerial data. And so we can actually work with them. We've created our own online platform that can actually be used to QC our data. So if you don't necessarily want to be sending copies of satellite or aerial imagery to QC teams or endpoints across your organization, we've actually created a pretty slick online tool so that you can look, visualize, edit, and quality control all of the data online. So it's just a matter of how your organization, what your preferences of your organization are. But it was something that we were asked to develop, and it's actually the tool we use internally. And so we're making it available to the individuals that we're working with, just to make sure that everybody has the same access to the information, despite what they have on the back end.
Yeah, Bill, I think you covered it well. From the software side and being able to actually work with these larger data sets, I think the state of where we are with visualization software is at an all-time high, and software are always evolving to be able to ingest complex data sets like satellite imagery or raw location-based service data. So the evolution is occurring both on the data side and the software side to process that data.
I have a question for mostly Sean and Tricia. San Bernardino County is an urban county, really, right? And there's a lot of change going on. So how are you going to deal with that change now and keeping that sidewalk and that data inventory up so that as your connectivity plan moves forward, that seems like something really important to do. How will you be able to stay on top of that?
Yeah, I'll jump in. I think so. As Sean mentioned earlier, San Bernardino County is the biggest county in the continental United States. It's huge. If I were to drive from San Bernardino to Needles, it would take 4.5 hours at least without traffic. So it's just funny to see, how different the landscape can be. In the southern tip of the county, it's very urbanized, but then there's a ton of desert in our county too. So there are things that will definitely change. There are things that won't. We are going to be relying heavily on input from our member jurisdictions, the cities and the county, to kind of help us keep data up to date. So, that this effort really took a snapshot in time of the data, but it is something that we're kind of planning ahead how we're going to manage it. I don't know that we 100% have that sorted yet, but we are aware and we will be working on it.
It's great that you're thinking about it. You know, what makes data useful is that we keep it up sometimes, right?
Yeah, it looks like Shreya's question is exactly along those lines. In terms of how frequently the data is going to be updated, I don't think that there's a clear definition on what that looks like. Let's say for the city of San Bernardino, they had field crews that went out and essentially did an inventory today on maybe a subset of the data that we collected and said, you know, this curb ramp didn't have a detectable warning surface during your inventory, but there is one now. We've implemented some ways within the service of that data for them to overwrite the values or overwrite the conditions that we collected with what is currently in the field today. And so that would be reflected immediately within the service. And so this is I wouldn't say a problem, but something that all agencies encounter very frequently now is how do we keep these very complex, specific data sets up to date and have those updates be reflected outwardly for agency use and public use. And so we're constantly trying to evolve the way we do that. But yeah, it's a great question. Yeah, great question, Shreya. It's a challenging component of data management.
Yeah.
So Bill,
sorry.
go ahead.
No, I was just going to piggyback on that just to say, you know, our agency is actually really small. There might be 80 people total at our agency. My staff, it's myself, an analyst, an intern. So we're kind of stretched thin sometimes, but, you know, I think it's good that we can work with those people that do know what it should be and kind of make sure that when they change things, they can let us know, or as needed, we can reach out to them too.
Great response. And Sean, that goes to the value of those. I don't remember the exact number, but you said there's like 25 organizations that are participating in this overall effort, and they all bring know-how to the table. But Bill, that begs the question for me as well. How often does Ecopia update their data? Because San Bernardino County relies on you, and you rely on other partners. Share a little bit about how often those updates occur in change management at Ecopia.
That's a great question, Shreya. Really, at the end of the day, we are converting massive amounts of that 3-band, 4-band, and LiDAR data into the vector base maps that we're creating. So there is a little bit of a limitation on the frequency of what is available from the raw data perspective. We are updating the entire country. Definitely all of the urban areas, so the top 200 MPOs on an annual basis after this year. And then we're going to be working with the NATE program that fills in other rural areas of the country on a 2 to 3 year rolling basis. So that's really what our main objectives are. We are trying to consume as much 3-band and 4-band as available. We're always very hungry. If you have your own sources, we're always available to work with that. But that's why we sometimes also merge satellite sources with our analysis, especially when it comes to rapid response or emergency change detection, just because it's so much more abundant and available to help update those maps. And we can actually merge both inputs so that you can have a little bit of the best of the both worlds. So you can still have that absolute accuracy and resolution of some of the components that are derived from aerial, but then also have that updated look when you're in an emergency situation. So there are some of our insurance clients who are sort of looking at us doing data sets every quarter, but it's on a case by case basis.
One more question in the chat here in the Q&A tab from Margarita. If I understand correctly, you are solving image classification problems with AI. Are you also developing any forecasting problems or routines?
So typically our organization has been mostly focused not just on time zero, but actually going and emergency response. But we've actually been starting to be requested from other organizations to start going back and looking at historic data. There's a huge wealth of information that can track that can track the growth of urban centers, that can look at natural resource management. There's a number of other features that we can start to look backwards on, and there's a wealth of knowledge that's stored in banks of terabytes of imagery data, that I should say petabytes of imagery data, that we really haven't even tapped, really have sort of shallowly tapped into the surface of. And so we are doing a little bit of a historic analysis, which can help with predicting what will happen in the future. But for predominantly, those are the use cases so far. But I'm always willing, I would always love the opportunity to learn more about a particular use case to see how we can support that.
Well, what a wealth of information from all of our presenters today. We only have a couple minutes left. I want to thank you all for participating today. In about 30 seconds or a minute, what would you all want folks to take away?
Data is very powerful. When you have access to it, when you invest in it, I think there's a big return on investment in how it can help you visualize things and plan ahead for the future.
Awesome.
Yeah, and I would say data literacy is also key. So there's so much data out there, the market is diluted, and so understanding what you're getting is just as important about, like, the quantity of the data.
Bill, anything?
Absolutely, Sean. I couldn't agree more with what you're saying. Especially in the AI field, you always want to make sure that you're getting great results with and someone with a proven track record. But I guess I would say is there's just a wealth of knowledge that's going underutilized with all of the great imagery that's being produced. And I think organizations like San Bernardino has done a great job of trying to amalgamate a lot of those different sources to help to drive to solutions. And so we really want to be able to convert all of this different data sets to try to open up all of these different applications that can be made available to organizations across the United States.
We're about out of time. I'm not sure how to pronounce the person's name. Devin Shu. You did provide a question in the Q&A. Let us respond to that offline. We do have your connection information, so we will get you an answer. With that, folks, I want to be mindful of everybody's time today. To our presenters, thanks so much. It was a wealth of information. We've greatly appreciated it. And to our participants, thanks for joining today and spending a little bit of time with us. I really hope you took something away today and learned something new.